Hello everyone, today I'm going to be talking about potassium and chloride. Now first, I'm going to be talking about the major functions of potassium in the body. Potassium is the principal intracellular cation in the body, and this means it is the most common cation for fluid inside cells. This also means it has a significant impact over membrane potential. This impact over membrane potential means it is crucial to both nerve impulse transmission and muscle contraction. This is as nerve impulses are simply a pulse of rapidly changing membrane potentials. It is also crucial to muscle contraction, as potassium is responsible for depolarizing the membrane after contraction. This essentially means that without potassium, muscles would be unable to relax, causing cramping and tetany. This impact over both contraction and nerve impulses makes potassium essential to maintaining a stable heartbeat. This also makes it essential to digestion, as peristalsis and segmentation would be unable to occur without muscle contraction. Additionally, calcium retention is influenced by potassium. When potassium levels are normal, it signals for the kidney to retain more calcium. This helps keep more calcium in the body and helps us have stronger bones. Additionally, as potassium is an electrolyte, it has an impact on osmotic pressure, causing it to have an influence on water balance throughout the body. This influence would include regulating blood pressure. Now onto chloride. Chloride is just about the opposite of potassium, but they still have very similar functions. While potassium is the principal intracellular cation, chloride is the major extracellular anion. This means it is a negative ion that is largely found outside of cells. This also means it has an impact on a membrane potential, but this impact is to a much lesser extent than that of potassium. Also, chloride has a major role in digestion. This is as chloride is essential to the generation of hydrochloric acid, which is then responsible for the mechanical breakdown of food in the stomach and the conversion of pepsinogen into pepsin, which is then responsible for digesting proteins. Hydrochloric acid also protects the body from infections, as the acidic environment it creates in the stomach can destroy most infections. Additionally, chloride is also an electrolyte, so its concentration in the blood and other fluids such as the plasma impacts fluid balance and thereby regulates blood pressure. Lastly, chloride is also essential for oxygen and carbon dioxide transport. This is as the presence of chloride impacts the affinity of hemoglobin for oxygen and carbon dioxide, allowing for them to bond and unbond, and thereby allowing them to transfer throughout the body. Now, for both potassium and chloride, there is not enough information to establish an RDA. So instead, there is an AI, meaning adequate intake, for both of them. The AI for potassium for men is 3,400 milligrams a day, and for women is 2,600 milligrams a day. For chloride, the AI for all adults is 2,300 milligrams a day. A UL or upper limit cannot be set, as a toxicity cannot occur from eating too much potassium, as it only occurs due to the extreme abuse of supplements or the use of medications. The UL for chloride is 3,600 milligrams a day. Now onto deficiencies. A potassium deficiency, also known as hypokalemia, has wide-ranging impacts on the body due to potassium's influence on nerves, muscle contraction, and fluid balance. Early on, people with hypokalemia will experience hypertension, kidney stones, and increased bone turnover. Later on, various irregular heartbeats can develop. These irregular heartbeats, otherwise known as arrhythmias, are seen on the left as it depicts the various EKGs for the different types of arrhythmias that can arise from a potassium deficiency. Muscle weakness throughout the whole body can also occur along with glucose intolerance, as the pancreas loses its ability to generate insulin due to the issues with membrane potential. These conditions can prove to be fatal without treatment and an adjustment to the diet. Now here's a video that covers a symptom I didn't mention along with covering the treatment of hypokalemia.
Excessive urination and excessive thirst. the function of the kidneys is to filter waste materials from the body and regulate fluid and electrolyte levels in the blood, including salt and potassium. They accomplish this by excreting waste and excess electrolytes in the urine. Moderate to severe hypokalemia can impair the kidney's ability to maintain a healthy balance of fluid and electrolyte levels in the blood, which can result in polyuria, an increase in urination. You may also notice increased thirst, known as polydipsia, severe muscle weakness, leading to paralysis. Muscle paralysis may be experienced by those with severe hypokalemia. When the body's potassium levels are too low, the muscles cannot contract properly and may even cease functioning completely. How is hypokalemia treated? Oral or intravenous supplementation is frequently needed to treat hypokalemia. While eating a diet high in potassium is beneficial, it does not always help to restore potassium levels, which is why it is important to have the patient treated by a doctor. The most popular form of treatment for mild to severe hypokalemia is oral potassium supplements. In rare cases, your healthcare professional might also need to adjust any other medications or address the underlying issues, including vomiting, diarrhea, or eating disorders. Your doctor may switch you to a potassium-preserving diuretic if you need to take one. Potassium chloride supplements ought to be utilized to treat both deficiencies, since hypokalemia frequently coexists with a chloride deficiency. Then again, always heed the counsel of your medical professional. Unless they're prescribed by your healthcare professional and you're being closely monitored, avoid taking potassium-only supplements. This is because overdosing on potassium can result in hyperkalemia, a condition where excess levels of the mineral accumulate in the blood. Heart arrhythmia, and other serious, perhaps fatal heart problems can be brought on by hyperkalemia. How can you
Now moving on to a chloride deficiency, also known as hypochloremia. Hypochloremia rarely occurs due to chloride being abundant in most diets. It is usually not caused by dietary concerns, but rather due to issues with water and electrolyte balance. These issues include vomiting, diarrhea, dehydration, and heart, kidney, and liver problems. There are no known symptoms to a chloride deficiency. This is due to a chloride deficiency always occurring with a deficiency of another electrolyte, usually sodium, and the symptoms of a sodium deficiency mask any symptoms a chloride deficiency would have. However, although not directly attributed to a chloride deficiency, some symptoms that may be influenced by hypochloremia are headaches, confusion, and seizures. Hypochloremia is also easily fixable, as chloride will return to normal levels quickly after consuming a chloride-rich food, some examples of which I will be providing later. Now on to toxicities. Potassium toxicity, or hyperkalemia, has many similar symptoms to hypokalemia. It also causes heart and muscle problems due to issues with membrane potential. Some of these problems include chest pain, heart palpitations, and various arrhythmias. The digestive system is also impacted, as the issues with membrane potential affect peristalsis and segmentation, causing problems such as vomiting, diarrhea, and abdominal pain. Now onto chloride toxicity, also known as hyperchloremia. The only known cause of hyperchloremia is dehydration. Chloride toxicity also only has one major symptom, and that is vomit. The vomit is caused by too much chloride irritating the stomach, as it affects the generation of hydrochloric acid. Now here are some excellent sources of potassium. One medium banana provides 425 milligrams of potassium for 109 calories. Half a cup of acorn squash provides about 525 milligrams of potassium for 69 calories. And 1 cup of potatoes with the skin provides 500 milligrams of potassium for 133 calories. Out of these foods, I eat both potatoes and bananas, but not acorn squash. I've never really had acorn squash, but I don't like squash in general, so I don't really plan on trying acorn squash in the near future. Now onto chloride. Some good sources of chloride include seaweed, which for 35 calories offers 115 milligrams of chloride, potato chips, which for 530 calories provides 790 milligrams of chloride, and cheddar cheese, which surprisingly for 400 calories provides 980 milligrams of chloride. Out of all these foods, I eat both potato chips and cheddar cheese, but I've never really tried dried seaweed, and I don't really plan to. Overall, good sources of chloride are really any food that contains good amounts of salt. This includes the foods I provided and numerous other processed foods such as processed meats and really any canned food. Also, you shouldn't really be trying to eat good sources of chloride unless you have a deficiency. This is as they usually have high amounts of sodium, which in excess can cause a variety of other problems, such as high blood pressure. Okay, that's all from me. Here are my sources, and thank you for listening.